Kutis, I welcome you all to today's class with immense pleasure. In the previous class, we studied about reflection of light and plane mirrors. Today, we will be studying about curved mirrors. The most commonly used curved mirrors are spherical mirrors. This type of mirrors you might have seen in your day-to-day life. See here, this is a sphere. If we take out a part from this, that can be a curved surface. If we polish any of this, we can get a curved mirror. If the inner side is polished and the outer side is coated, we will get a concave mirror. See? If the outer side is coated, this will act as a concave mirror. And if the outer side is polished and the inner side is coated, we will get a convex mirror. Okay. Let this be a concave mirror. Come on, let us study more about this mirror. There are some terms related with this mirror, that is pole. Pole is the center of the mirror, and then principal axis. Principal axis is the line which passes through the center. It can be an imaginary line which passes through the center. And F, that is principal focus. F is principal focus. Then C is the center of curvature. Principal focus means if we make the mirror towards a distant object and find the image of the mirror, that image of the distant object will be confined at a point. This point where the image is confined is called principal focus. And C is the center of curvature of the mirror. That is, if we consider this as a part of a sphere, this will be the center of the sphere. If this is the part of a sphere, this will be the center of the sphere. And F, that is focal length. Focal length is the distance from the center of the mirror to the principal focus. That is, focal length is denoted by small letter F, and capital letter R is a term there, that is the radius of curvature. This radius of curvature will be equal to 2 times focal length. Okay, 2 times focal length. That means this distance and this distance will always be equal. This is pole is called denoted by the symbol P, and these two distances are always equal. There are certain rules for the image formation in concave mirror. Let us see those rules. The first rule is light ray coming parallel to the principal axis after getting reflected from the mirror passes through the principal focus. Okay, light ray coming parallel to the principal axis. Light ray coming parallel to the principal axis after reflection passes through the principal focus. This is the first rule. Now, the next rule is light ray coming through the the light ray coming through the principal focus will be reflected parallel to the principal axis. So this is the next rule. Okay, then next rule is the light ray which passes through the center of the curvature will be reflected back along the same direction. Light ray falling on the mirror through the center of curvature will be reflected back along the same direction. Okay. Now, another rule. The light ray which impinges the lens at the pole will be reflected like this. That is, it will have the angle of incidence equal to angle of reflection. These are the rules we should know while drawing ray diagrams. Now let us see some ray diagrams. Let us consider the object B at infinity. Now let us see what will happen to the light ray coming from the infinite object. So, light ray coming parallel to the principal axis. After reflection will go through the principal focus. Like this, light ray will be coming from all direction. It will be passing through the principal focus. So, we will get an image at the point F. Okay. What will be the type of the image? Very diminished image. Okay, very diminished inverted image. Diminished means small, very small inverted point image. Now, if we place the object beyond C, let us place the object here. What will happen to the image? Where will be the image formed? That is what we are going to see now. Light ray coming parallel to the principal axis. After reflection passes through the principal focus, and light ray passes through the principal focus. After reflection goes parallel to the principal axis. So where will we get the image? See, where will we get the image? We will get the image where the two lines meet, is it not? Where is the image? This line after reflection passes through here. And this ray after reflection passes like this. These two meets at a point after reflection. Here is the position where we will get the image. What is the image? Inverted image, diminished image. The size of the image is much less than the object. Okay, so we will get the image like this. Now let us consider a ray which passes parallel to the principal axis and after reflection passes through the principal focus. Another ray which passes through the principal focus. After reflection passes through parallel to the principal axis. Now where will we get the image? The two reflected rays meets at this point and here we will get an image which is inverted image of the same size as that of the object. Now let us place the object between F and C. There will be two rays we consider. One ray coming parallel to the principal axis after reflection from the mirror passes through the principal focus, and another ray passing through the principal focus after reflection passes parallel to the principal axis. It will be passing parallel to the principal axis. These two rays will meet at a point after reflection, and this point is where we will get the image. The image formed will be an inverted image. It will be large in size than that of the object, but it is a real image. Real inverted magnified image will be obtained beyond C. Now the object is placed at the point F. We are considering two rays. One ray coming parallel to the principal axis after reflection passes through the principal focus, and another ray which impinges at the pole reflected with an angle of reflection equal to the angle of incidence, and these two rays never meet and we will get the image at infinity. Now let us place the object between P and F, that is pole or optical center of the mirror and principal focus. Now here also we will be considering two rays. One ray which passes through the center of curvature. After reflection it will be drawn backwards, and another ray which passes through the principal focus after reflection from the mirror. This will also be drawn backwards, and these two rays will meet at a point, and this is where we will get the image. But this image is a erect image, and this will be a magnified erect image, but it is a virtual image. Let us see the image formation in concave mirror once again. If the object is at infinity, the image will be at the principal focus, and the image will be diminished and inverted image. Is it not? Now, if the object is beyond C, the image will be between C and F. The size of the image will be less in size than that of the object, and it will be an inverted real image. Now, if the object is at the center of curvature C, image will also be at the center of curvature B, and the size of the image will be as the same size of the object, and it will be a inverted image. Now if we place the object between C and F, that is center of curvature and principal focus, we will get the image beyond C. That image is an inverted image, and it will be high in height. That is, it will be, the size of the image will be more than that of the object. Now, if the object is at the principal focus, we will get the image at infinity. If the object is between the principal focus and the pole of the mirror, we will get a erect image at the back of the mirror. That image will be a virtual image. With this, I conclude today's class. We can meet in the next class with more about concave mirrors. Thank you.